Right, now let's discuss about the formula for diffraction grating. Okay. First of all, diffraction grating start from zero order. Right, here I just want to emphasize again, it start from zero order. The formula, okay, for diffraction grating is only for bright fringe. So this is just the bright fringe formula. Okay, and we can consider diffraction grating is in phase source. Yeah, we can consider it like in phase source. Right, in phase. So the formula to form bright fringe for diffraction grating as in phase source, the formula is d sine theta equal to n lambda. Do you still remember this formula? Is very similar to the double slit bright fringe also. Okay, it's very similar to the double slit bright fringe also. If you look at the double slit again, the formula for double slit, here it is. Okay, this is the double slits formula. Okay, so the double slits formula, bright fringe. Okay, double slit is also in phase source. Okay, the bright fringe formula is d sine theta equal to n lambda. So it has the exactly same formula as the double slit in phase source. Yeah, bright fringe, d sine theta equal to n lambda. Yeah, so we can say diffraction grating is like double slit, okay, in phase. So right here, so the diffraction grating, the formula d sine theta equal to n lambda is similar to the double slits of which is the bright fringe formula. Yeah, and it is also in phase source. Okay, actually d sine theta is the path difference. Yeah, you can see here, this is the path difference, which is equal to n lambda. Yeah, so yeah, we can say this is actually delta L equal to n lambda also, right, for the bright fringe, okay, in phase, which is d sine theta equal to n lambda. Now, what is the d? D is the separation between the slits. So what is actually the diffraction grating? If you look at here, diffraction grating is actually a plate that contain many parallel lines or parallel slits. It's a plate which has many, not just one, but many slits. Okay, it has many slits. So it's just like this one. You see, these are the slit. These are the slit. The white one is the opening, the slits, and D is a separation between the slits. Separation between the slits. Right. So, and the black one is the line that you see. The line that you see on the slit. Yeah. The line actually is not the slit. The line is actually separating the slit. Okay. So, how to find this slit separation? Sometimes the question will give you number of lines per unit length. This is the lines. Okay, number of lines per unit length, and this is D is the slit separation. So to find the slit separation is you just take 1 divided by number of lines per unit length. Actually, if we look at this formula is actually 1 meter. 1 meter divided by n. 1 meter divided by number of lines per unit length. Then you can get the separation between the slits. Okay. You want to get D, just take 1 meter divided by number of lines per unit length. So D is also meter, yeah, measured in terms of meter. So there is one very important unit conversion here that you need you to know. Let's say the question gives you the number of lines per unit length is in non-SI unit, because what we need is only SI unit. Yeah, SI unit. But what if the question give you well, we need SI unit. What if the question give you non-SI unit like per cm instead of per meter? I can say the unit actually, the unit for n is actually yeah, you see, this is the number of lines per unit length. So it is the unit for n is The unit for n is per meter, but for the d, the unit is in meter. Okay, so this is lines per unit meter. But now, what if the unit is per cm? That means this is what is mean by 100 per cm? That means it has 100 lines in 1 cm. Yeah, that means in 1 cm long, it has 100 lines. It has 100 lines. Yeah, or we can say the diffraction grating has 100 lines in 1 cm. This is what it means. Yeah, it has 100 lines in 1 cm. So how to find the slit separation? Very simple. You just take, again, just use the formula 1 over n. You just divide into 1 over n, then you get the d. So you get 0.01 cm. Okay, if the n is in per cm, your d you surely get cm. Once you convert to d, then here you can change unit. Centimeter become meter. Centi is exponent negative 2. Then you get this. You get the separation in meter. What if the question give you the d and ask you to find the n? So it give you the d in millimeter. Want to find n in SI unit. So again, unit conversion. So you can see my process here. I always convert the unit when it is in d. We only convert the unit for separation between the slit, which is the d. I don't convert the unit for n, because if you convert the unit for n also can, but I afraid you you will make a mistake. Okay, it's easier if you convert the unit while in the separation, which is the d. Okay, like you see here, I don't convert the unit 100 per cm. I just maintain the unit. Once I calculate the d, then only I convert the unit into meter. Same goes to this one. Given the d, I convert the unit first in the d before I substitute into the n. Yeah, so like this one, millimeter, I change to meter, so exponent negative 3. Once I convert to meter already, I can substitute into the formula to find the n. The n also in SI unit. Like this one, what it means here is here it has 1 exponent 4. What it means here is it has 1 exponent 4 lines in 1 meter long. Yeah, in 1 meter long. Okay, so always change the unit while in D. Try not to change the unit while in N, because I afraid you make something mistake like this. If you change the unit in N, I afraid you make this mistake. 100 per cm is or centi is exponent negative 2. Exponent negative 2 per meter. This is wrong. You understand that? Because it is actually this is wrong, because it is actually not exponent negative 2. Actually it should be, how you change the unit is you should change it to 100 per 1 cm, and then only you change the unit over here. Centi is actually below, not above. Centi is actually below. So here is exponent negative 2 meter. So if you go above, it becomes positive 2. It becomes like that. Actually, this is the way. So instead of exponent negative 2, actually is exponent 2. You change like that, it's wrong already. I hope you know where's the mistake. Yeah, I hope you know where's the mistake. This one is the correct one. Okay. If you still want to change the unit in N, this is the way to do it. Make sure the centi go below first, because this is a centi negative 1. It's not centimeter. It's centimeter negative 1. It should go below first, then only you convert the unit. Okay, then it's correct. Okay, so now or the easier way is you just maintain the unit in N. You only change the unit while you do the D. While you do the separation, which is the D, then here you change the unit. Then it's okay lah. It's easy lah. Okay, then it will be easier. Now, I already talked about the unit conversion. Now, here this is one very important thing. Okay, this is one very important thing. D is the number of, this is a slit separation, N is the number of lines per unit length. Okay, now here is one very important thing I want to talk about. What is the total bright fringe or dark fringe that can be observed on the screen? And what is the maximum order of bright fringe that can be observed on the screen? They are both different. What I mean here? What I mean here. So sometimes the question may ask, like you see here, how many bright fringe you can observe in this screen? How many bright fringe you can observe? You can observe 1, 2, 3, 4, 5. You can see the total bright fringe you can see here. What's the total bright fringe you can see here on the screen? You can see 1, 2, 3, 4, 5. You can see 5 bright fringe, isn't it? That is the total bright fringe that can be observed on the screen. But what is the maximum order? What's the maximum order of bright fringe that can be observed on the screen? Is it the same as the total bright fringe? The maximum order of fringe can be observed on the screen. Is it the same as total bright fringe? No, the maximum order is just 0, 1, 2. The maximum order is just 2. The maximum order, yeah, look at here. The maximum order of bright fringe that can be observed is just 2. It's just n equal to 2. It's not. So why there's such a difference? Why the total bright fringe is 5, but the maximum order you can see is just 2? What's the relationship between these 5 and 2? What's the relationship? So now, how to find? First of all, how to find this? How to find this maximum order of bright fringe that can be observed? Yeah, I can just write this is n max. Okay, n max. How to find this maximum order? Very easy only. So my question is, what is the maximum order of bright fringe that can be observed on the screen? It is happen when sine 90. Using the formula, this one, yeah, d sine theta equal to n lambda for bright fringe. So the diffraction grating, I'm talking about diffraction grating. Diffraction grating. Okay, so the for the bright fringe, the formula for bright fringe is d sine theta equal to n lambda. So in order to see the maximum, order of bright fringe, you put sine 90. You put sine 90. Why put sine 90? Yeah, many questions. Why put sine 90? Because it's just like if you want to see the maximum order, is like when this theta is equal to 90 degree. It's like now the ray, this is theta 1. If you want to see until the end of the screen to the ceiling, the maximum order that on the screen, if the screen is like in very big screen, very big screen, it's a very big screen. So the maximum you can see is when the ray is 90 degree. When the ray is the theta is in 90 degree. Then you will reach to the top of the screen to show what's the maximum bright fringe. You understand? When the theta is 90 degree, that's why we say sine 90. Okay, that's why we say sine 90. So from here you can find the maximum order. Okay, sine 90 equal to 1. So just lambda just go below. So maximum order is d over lambda. That's a formula. That's a very important formula for diffraction grating. So the maximum order is d over lambda. Okay, when sine 90. So let's say my maximum order I got here for this example, like this one, the maximum order I can find is 2. Let's say my maximum order. Let's say my maximum order, like this one, I got n max equal to 2. Okay. Yeah, I use this formula d over lambda, and I calculated my n max equal to 2. Right. So d over lambda, I got 2. N max equal to 2. So my maximum order of bright fringe that can be observed is maximum order that I can observe is 2. You see that? I can see 2. Like this one lah. Like this one, maybe this one is considered n. My n maximum. My n maximum is 2. Understand or not? So remember, the order has both sides. You have top and bottom. Have top and bottom. So this 2 means n order 2 means this n1 and n2. But you remember here got n1 and n2 at the bottom. So that's why to find the total bright fringe, you need to take what? You need to take the n max. You need to take the n max multiply 2, because it is what? It is the top order plus the bottom order. Top plus bottom. Understand or not? The order is just for one side. This one, maximum order is just for one side. Just for one side. Maximum order is just for one side. Total is we can say total is both side. Both side, top and bottom. Plus, okay, total top and bottom. That's why the maximum order multiply 2. Okay, 1 and 2, 1 and 2, and you are still one more at the center. Don't miss it. Don't miss it. Just now we got the top and the bottom, isn't it? That is 2 fringe here, 2 fringe here. That's why n multiply 2. Don't forget, we still have one more center. So need to plus 1 more, plus 1. So this one plus 1 is what? The 0 order. Because the 0 order is n equal to 0. This one is n equal to 0, which is the central bright fringe. The 0 order is not counted in the order. It's not counted in the order because it's n equal to 0. So that's why this one become, since the maximum order is 2, so 2 multiply 2 plus 1, that's why I got 5. That's why I got 5. That's why I got 5 order. Understand or not? That's why I can see 5 bright fringe. Understand? That's how we do it. Okay, that's how we do it. You can see 5 bright fringe. Now you see here. So what I can say, this is a very important thing. Okay, this one lah. So this is the one. Yeah. So it's different. Yeah. So it's different. The total bright fringe that can be observed on the screen is 2n plus 1, but the maximum order is just the n max lah. Total bright fringe is 2 times the n max because we have top and bottom, and then plus 1 some more. Plus 1 because the 1 is the 0 order central bright fringe. Okay, now let's say the question. Let's say in one question, it give you you calculated this one. The maximum order you can see. Let's say for another type of question, another question, you calculated n max equal to, let's say the n max equal to, let's say he don't give you the figure. Let's say this figure is not given. Like this figure is given, easy. We can count one by one. 1, 2, 3, 4, 5, isn't it? Very easy to calculate. To find the total bright fringe that can be observed. What if the figure not given? Figure not given, but just based on equation, it just give you the value of d, the lambda, and you need to find the maximum order by yourself. So how to find it by yourself? You substitute the sine theta with sine 90, and you can calculate the n max. And let's say you calculated the n max equal to let's say he calculated n max equal to 2.98. 2.98. Let's say, yeah, it's not a nice figure. 2.98. So what's the maximum order that can be found? Can be found on the screen? Do you write n equal to 3? The n equal to, we need to, because the order has no decimal place. There's no decimal place. We cannot put decimal place. No decimal place. So how? So do we put 3 or 2? Do we put 3 or 2? Not 3. Although this one is 2.98, is more than 0.5, but the screen does not reach that yet. So the correct answer, should be, the correct answer is not 3, but it's actually 2. Understand or not? The correct answer is 2. Don't put 3. 3 is wrong. Although you get 2.98. Why? Because the screen, let's say, you see the screen. The screen, let's say, you got n equal to 1 bright fringe. You can see n equal to 1 bright, n equal to 2 bright fringe. And then, it didn't reach the n equal to 3. N equal to 3, it just reached the maximum 2.98. But 2.98 is not the bright fringe yet. I mean, it doesn't reach the n equal to 3 yet. It doesn't reach the n equal to 3 yet. So it doesn't reach it yet. So you cannot write as n equal to 3, although is if you round it up you get 3, but it doesn't reach there yet. What you can see is just this one. This is the maximum order. You can see only this one. Okay, you can see only this one. Can see this one, but this one not reach yet. Not reached the order 3 yet, because 2.98 not reached 3 yet. So the answer is not 3. The answer is 2. You can see only 2. Understand? So what is the total bright fringe you can see? Yeah, total bright fringe you can see. Total bright fringe you can see is 2n max plus 1, which is 5. Yeah. Top and bottom and the central some more. Yeah, central we have 0 order some more. Yeah, and then here we have 1 and then we have 2. So if you got the order equal to 2.98, the question asks you to find the maximum order is just 2, not 3. And to find the total bright fringe can be seen on the screen. It is 2 multiplied 2 plus 1, 5. It's not 2 multiplied 3 plus 1 becomes 7, which is wrong. Okay? One more thing. Let's say you got the maximum order equal. Let's say I give you another quiz. Let's say the n maximum you got is 17.95. Maximum order you can see is 17.95. So what is the total? Yeah, this is the maximum order of bright fringe that can be seen. Yeah, that can be seen is 17.95. So what is the total bright fringe that can be seen? What is the total bright fringe can be seen? What is it? So how you do it? This is maximum order you can see is 17 or 18. Just chop it off. So it's not 18. It's not 18. It's actually 17 only, you can see. Understand? It's only 17. And then apply the formula. 2n plus 1. Yeah, 2n maximum plus 1. Which is 2 times 17 plus 1. So what you can see is 34 plus 1 is 35. Bright fringe can be seen. Top has 17, bottom has 17, central has 0 order. So 17 plus 17, 34, 34 plus 1, 35. You can see 35 bright fringe on the screen. Okay, I think I have discussed everything about this. All right. Yeah. So all the important things I have discussed. Remember, to find the maximum bright fringe, that can be seen on the screen, you substitute sine 90, and then this 90 equal to n max lambda. So you find the n max from here, and then from n max you can find the total bright fringe. From the n max, maximum order can be seen is this one. Total bright fringe can be seen is 2n max plus 1. Okay, top and bottom and plus the central. Let's say the question give you let's say another situation. Let's say the total bright fringe can be seen is let's say 27. 27. Total bright fringe can be seen on the screen is 27. So what is the maximum order that is found on the screen? Maximum order. Easy. Yeah, maximum order. So what is the maximum order of bright fringe that is formed on screen? Yeah, what is formed on screen? What's the maximum order of maximum order of bright fringe that is formed on screen? Easy. So 27 just equal to 2n max plus 1. So minus 1, what do you get? Minus 1, so 2n max is equal to 26. So what's the maximum order you can see on the screen? 13. 13. So the maximum order that is formed on screen is only 13. Understand? 2n max equal 1 go to here minus get 26. So n max, the maximum order that can be formed on screen is only 13. Okay, so that's all for this video, and let's go on to the next one.